In the last video, we solved problem number 24 of the Ahmed's mathematical papyrus using the method of false position. In the method of false position, we assume an incorrect answer at the start, but we use that to arrive at the correct answer in the end. In this video, we're going to solve that same problem, but we're going to follow the solution as listed in the actual papyrus using unit fractions or Kemetic fractions, as well as Kemetic multiplication by doubling. So in the Nile Valley, in African mathematics in the Nile Valley, all fractions were expressed as unit fractions. A unit fraction is a fraction that has a numerator of 1 and a denominator of anything else. So, for example, if I had a math problem where I wanted to express that 3/4 of my farm had been flooded, I would represent that 3/4 as 1/2 plus 1/4. I would not represent it as 1/4 plus 1/4 plus 1/4, because even though that's correct, a Kemetic fraction always uses the least amount of fractions and does not duplicate numbers. So the duplicate 1/4 wouldn't work. So 1/2 plus 1/4. So how do we find a unit fraction if we have a non-unit fraction, such as 7/9? Well, first thing we think about is what is the largest unit fraction that can go into it? 7/9 here is close to 1, so we can see that it's larger than 1/2. So we know it's going to be 1/2 plus something. So to find that something, we just start with some subtraction. So we'll do 7/9 minus 1/2. And to subtract this, we need common denominators. The common denominator here will be 18. So 7/9 will be 14/18. And 1/2 will be 9/18. And when we subtract that, we will get 5/18. All right, so we see that 7/9 is equal to 1/2 plus 5/18. But 5/18 is not a unit fraction, so we have to do this process again for 5/18. So we can say 5/18, and 5/18 is smaller than 1/2, so we can't subtract 1/2. 5/18 is also smaller than 1/3, so we can't do that. But 5/18 is larger than 1/4, so we can subtract 1/4. So let's do that. So 5/18 minus 1/4, we'll need common denominators here. Common denominator will be 36. So 5/18 will become 10/36. And 1/4 will become 9/36. When we subtract that, we will get 1/36, which is luckily a unit fraction. So we can say that 7/9 is equal to 1/2 plus 1/4 plus 1/36. And this is how it will be represented in meta nature. So if we wanted to actually draw the meta nature, it would look like this. So this is 1/2. 1/4 looks like this. So we have our little mouth, letter R, and then we'll draw 4 single lines. That's 1/4. And then 1/36 would look like this. So also have a mouth. And 30 would look like this. 1, 2, 3. And then 6 would be 6 marks. 1, 2, 3, 4, 5, 6. So this would be the way that we would represent the fraction 7/9 in Kemetic mathematics and Nile Valley African mathematics. All right, so it's the sum of 1/2 plus 1/4 plus 1/36. Another skill that we need to be able to tackle this problem is to be able to use multiplication by doubling. So let's take an example of that and see how that works. So let's say we have 17 and we want to multiply it by 53. The way we do that in Kemetic mathematics and Nile Valley African mathematics is we have 2 columns. The column on the left, where underneath the 17, we're going to start with 1, and we're going to keep doubling until we have enough numbers that we can find a sum that equals 17. So we're going to double 1, that's 2, 2 and 1 is 3, that's too small, double again, 4, double again, 8, double again, 16. Okay, now that I've doubled this many times, I'm going to star 16 and 1, because if I take 16 plus 1, that gives me 17. I'm going to come over to the next column under the 53, and I'm going to start with 53, which is the number, and I'm going to double this exact same times to match the number of times that I doubled in the left column. So 53 doubled is 106. 106 doubled is 212. 212 doubled is going to be 424. 424 doubled is going to be, and I'm getting off of my spacing here, so let me fix that. So that's going to be 424, and 424 doubled is going to be 848. So now the numbers that I starred in the left column, I'm going to select the corresponding numbers in the right column. So I can just draw an arrow here for emphasis. So that is 53 and 848. And I'm going to add those together. So I'm going to say that the answer here will be 848 plus 53, which we can solve by mental math, knowing that 848 is 800 plus 40 plus 8. 53 is 50 plus 3. So the sum will be 800 plus 40 plus 50 plus 8 plus 3. So 800 plus 40 plus 50, that's 890. 8 plus 3 is 11. So we have 890 plus 11, that's 890 plus 10 plus 1, that is 901, which is our answer. So 17 times 53 is equal to 901. We can also use this same method to solve simple one-step equations. So for example, let's say we have 12 times some unknown number is equal to 84. And we want to find out what that unknown number x is. So we're going to set this up, but this time our column in the left is going to be our unknown number, which is x, and the column in the right will be 12, and we know that it has to equal to 84. So here we're going to start by doubling the column on the right, which starts with 12, and we're going to double that as many times as we need to in order to get a sum of 84. So we'll start with 12, we'll double it, that's 24, we'll double it again, that's 48, we'll double it again, that's 96. Okay, let's see, and then on the left column, we're going to correspondingly double starting with 1. So it'll be 1, 2, 4, and then 8. We can immediately cross out the 96 and then this corresponding 8 because that's bigger than 84, right? So we know that's not going to be it. The remaining three numbers, if we add 12 plus 24 plus 48, that gives us 84. So we're going to star those because those are the special numbers that we're going to choose. And then we're going to draw arrows over to the corresponding numbers on the column in the left. And these will be the numbers that we add to get our final answer. So our final answer here, x, is equal to 1 plus 2 plus 4, which is 7. Right? So x is equal to 7. So we see that we can use multiplication by doubling, essentially division by doubling to solve this type of problem. But I know what you're saying. You're saying, oh, that's too easy. Use the easy examples. Teachers always like to use the easy example. What if you have something that's not a nice whole number? All right, well, I'm glad you asked that question because we can still use the same exact method. So let's say, for example, we have the problem 8 times x is equal to 15. All right, so this will not give us a whole number. Let's see how we can use the same method again here. So I'm going to set it up. I'm going to come over here, set it up, and put my x in my left column times 8 in the right column is equal to 15. So we're going to start out by doubling in the left column as many times as we need to get a sum of 15. But immediately we see the problem, right? We double once, we start with 8, that's once. We double twice, we get 16. That's already larger than 15. So, oh my goodness, what do? We half it. So instead of doubling, we can also half. So now we're going to find half of 8, which will give us 4. Okay, so now, okay, 16 and 4, that's 20, that's too big. 8 and 4, that's 12, that's too small. So we're going to half again and go a fourth. A fourth of 8 would be 2. So now we have, let's see, 8 plus 4 is 12, plus 2 is 14, still too small. So let's half it again. And that will give us 1/8. 1/8 of 8 is 1. Now we have exactly what we need because if we do 1 plus 2, that's 3, plus 4, that's 7, plus 8, that is indeed 15. So we can again come over to the left column, choose the corresponding numbers, and if we add these numbers up, this 1/8 plus 1/4 plus 1/2 plus 1, we get the answer. And here we see the benefit of using the Kemetic fractions, the unit fractions. We don't actually have to add these fractions up. We're just going to write them as they are, as the sum of these unit fractions. So the answer here is 1 plus 1/2 plus 1/4 plus 1/8. So this is how the correct answer would be written in Medu Neter. In the next video, we're going to apply these techniques to solving Ahmed's mathematical papyrus problem number 24 according to the solution given in the ancient African text. So check it out.